All right, y'all. So this is the next part of the unit. It's called compound inequalities. So this is new material. A compound inequality is two or more inequalities graphed on the same number line. So you can see that there's an inequality here. Zoom in. There's an inequality going from negative, like less than -4, and greater than 1. Um, so for this specific inequality, anytime your arrows are going to the left and to the right, we call it an or compound inequality. So it's written like this. You basically just write the inequality, the first inequality, because it's going to the left. This would be x is less than, and this one can also equal because it's a closed circle over -4. So this is x is less than or equal to -4, or x is greater than +1. And +1 does not have a line underneath because if you could see, it's an open circle. So or inequalities always have the arrows going left or to the right, and you actually have to write the word or in between, and you just write the two inequalities. It's the easier of the two. The second type is called an and. So interval notation would be this. It goes from -infinity, because it goes left forever, and it stops at -4, but it could equal -4, so you have a bracket. Then you have a union. We've talked about the union before. The union, um, you need that when you have to write two intervals, and you have two intervals here. So then you do 1 to infinity, 1 has a parenthesis, infinity has a parenthesis. 1 has a parenthesis because it's an open circle. So the or will always have a union. It literally means or. Um, and then if you're writing it as an inequality, you actually have to write the word or. Okay, so anytime you have an or inequality, you literally will have two inequalities, and you'll have the word or in between them. And so what you have to do is you have to solve each inequality like individually. So there's two different inequalities. You kind of draw a line. I'm going to have to draw or solve this one first, and then solve this one. So the very first thing you have to do is you have to subtract 4 from each side. And so I'm going to subtract 4, and I'm going to be left with 3x less than or equal to 10 minus 4 is 6. And then I'm going to divide by 3, and x is less than or equal to 2. I didn't have to do anything with my inequality symbol. Like I didn't have to flip it because I'm not dividing by a negative. I'm not multiplying by a negative. So I keep the same symbol every time. Then I put the word or in between. Now I'm going to solve this one. This one's pretty simple. I just have to divide by 5, divide by 5. 45 divided by 5 is 9, and I keep my symbol. So I have two things. I have x is less than or equal to 2, and x is greater than 9. So I'm going to plot each of these individually. Because I have or, I know my final answer is going to have an arrow going to the left and an arrow going to the right. So I find 2, positive 2, and I'm going to have a solid line. And because it's less than positive 2, I'm going to shade to the left. So what I did is I graphed that one first. Then x is greater than 9, so I find 9, open circle, goes that way. That's my answer. And then if I wanted to do the interval notation, it'd be -infinity to positive 2. Positive 2 gets a bracket, union, 9 to infinity. Both with parentheses because 9 has an open circle, and it goes toward infinity. And that's it. You just have to solve each one of them, and you should know that an or always is going to be to the left and to the right. So let's see. Let's do one. That's a good one. Let's do question 3. Question 3, you have or again. So I know I'm going to have to solve these two individually. And I'm going to start by subtracting 8. And when I do that, I get negative 3y. I bring down the less than or equal to. And then, whoops, not what I wanted to do. Clicked the wrong button. Okay, so then negative 7 minus 8 is negative 15. I divide by negative 3. I divide by negative 3. Because I'm dividing by a negative on the bottom, my inequality symbol changes, and then negative 15 divided by negative 3 is positive 5. However, you have to remember to flip your symbol. That's what we learned when I was here. You bring down the or, then I'm going to do this one. I'm going to add 3. I'm going to bring down the 10y, less than or equal to. Negative 33 plus 3 is negative 30. I divide by 10. I divide by 10. And this time, I do not have to flip the symbol. I know there's a negative right here, but because the negative is not on the bottom, because I'm still dividing by positive 10, I do not have to flip the symbol. So my symbol stays the same, and then that equals negative 3. So here's the two things I got. I have x is greater than or equal to 5, and I have x is less than or equal to negative 3. So the way I'm going to graph this is I just graph them individually, right? This one's a less than, so I'm going to start with this one. So at negative 3, that would be right here. I have a closed circle, and it's less than, so I shade to the left. And then I look for 5, 4, 5. I also have a closed circle, and I shade to the right. So it just depends on the problem. You could have two closed circles. You could have two open circles. You could have one of each like we did in question 1. But that is how you do an or inequality. And so some of these other ones get really complicated. There's fractions involved and whatnot. But as long as you could do that, um, without the fractions, you're good. So if you could do question 2 as well, um, you should be good on or inequalities. And so you subtract 6, you're left with n is less than or equal to negative 1. And that one's just solved. I subtract 7. I'm left with 9n is greater than or equal to 36. I divide by 9, keep my inequality symbol. No need to flip any symbols here. So I have my final answer is n is less than or equal to negative 1, or n is greater than 4. So that's one way to write it. The other way to write it would be this, well, I think it's kind of hard to do the interval notation until you actually graph it on the number line. So let's graph it on the number line. At negative 1, which would be right here, I have a closed circle, and that one is going to be shaded to the left because it's less than. And then at 4, open circle, shaded to the right. So now my interval notation starts from negative infinity. It goes to negative 1, so negative infinity to negative 1, but at negative 1 I have a bracket because it's a closed circle. I have a union, which means the same thing as or, and then I go from 4, then it goes to infinity. 4 has a parenthesis because it's an open circle. So that is case 1 or type 1 of compound inequalities. It's called or inequalities.